Hi, I'm Mr. Phillips Carey. I also go by Mr. PC, and this is the first lesson that I will be teaching for you. I'm sorry that it is in virtual format, and I hope you guys understand that I'm trying to get these lessons out the way, so that way, like the first couple lessons during and in the classroom are not all about like math-related concepts and very frustrating for you guys to go through. So the first lesson's on scientific notations. What I would like you guys to get out right now is a pencil and a spiral notebook that you will possibly keep for the IB chemistry course. And then after you watch this video, I would like you guys to log into Schoology, and in this folder where you found this video, I want you guys to complete the Jamboard that is there. Okay, so there are two kind of lessons that I'm going to be covering in this. The first one being scientific notation, and the second one being significant figures. So let's dive into scientific notation first. So if you had some teachers like Mugambi and Asherle, you would know what scientific notation already is. It's an expression that allows you to see decimals in a format that does not show you all the placeholders that are there. So for example, if I took that lovely expression of how many kilometers were there, that's a very ugly number, but scientific notation allows us to know we can change that number to 1 times the negative 15. And we know this because we moved the decimal place over to the right, I apologize, at least 15 times, so that way 1 would be the main number in front. So let's break down scientific notation. It's a number that's always in front of the times 10, that's between 1 and 10, where n is an integer that shows you how many positive or negative movements of the decimal place that you moved. So if n is positive, then the number is greater than 1, but if n is negative, it means the number is less than 1. So putting scientific notation in a calculator can be very, very confusing. The first thing that you need to know is where this EE button is. On the calculators, when you get back to school, there is a little tiny blue button on every single one of the calculators that is known as the second button. This second button allows you to press this EE function, where EE essentially stands for an exponential exponent, which potentially means times 10 portion on your calculator. So let's say I wanted to do 4.56 times 10 to the negative 18th kilograms times 8.35 times 10 to the negative 21st kilograms. I would put that in my calculator by pressing 4.56 second EE negative 18 times 8.35 second EE negative 21 and getting enter. And then sometimes I put this in blue to let you know a little bit more about it. The EE button is the button right above the 7 on the calculator that you guys will be using, and it looks like a comma, but once you hit the second button, it literally should be highlighting the blue for you. And that's it. That's all I need you guys to really know about scientific notation. So now let's get into something that was possibly also covered by Mugambi and Asherle, significant figures. So I still want you guys to make sure that you still have your lovely notebooks out. And this is a great time to say, if I am moving way too fast, go ahead and press pause on the video so that way you can record the slide that I'm currently on. Okay, again, you're going to be completing a Jamboard after you have completed all of this lesson within the lovely folder that you are in right now. So there are a total of 6 rules of significant figures. But significant figures are critical when reporting scientific data because they give the reader an idea of how well you can actually measure / report that data. And so rule number 1 is, please know that all non-zero numbers, meaning 1 through 9, are always going to be significant. So some examples I have here is 456,789 centimeters has 6 significant figures because all those numbers aren't 0. And then if you look down, it just shows you that all the numbers that are not 0 are significant to it. But if we look at the last example where it says 0.2376, that 0 is not significant, so we can only count the 4 numbers that are not 0. So rule number 2 says all zeros between non-zero numbers are also significant. So if we have a 0 sandwiched between a couple numbers, that means that those numbers, that 0, is significant. So for example, 250,340,789, those zeros in there are significant, so therefore there are 9 significant figures. It's the same thing if we have 2 zeros sandwiched with each other, so 23.5004 has 6 significant figures because those 2 zeros are sandwiched between a 5 and a 4. Rule number 3 says all zeros which are simultaneously to the right of the decimal point and at the end of a number are always significant. So if we're talking about decimal points, any zero after the decimal, if it has a 0 after a number, those numbers are significant. So 45.0 meters, those 3 significant figures are significant because the zeros after the decimal place. It's the same thing as if we look at the very last example for this, where it's 0.00760. The zeros in front of the number are not significant, but the 0 after the 6 is significant because it's showing that it is exactly 0.00760 picograms. Okay, so making sure that you know that the numbers before the number are not significant, but the numbers after the 0 after the number are significant. All right, rule number 4. The leftmost 0 appearing in the front of the non-zero digits are not significant. They are only placeholders. And this is what I was trying to get to when I said that with the last example. So the numbers in front of the numbers, even if it's after a decimal place, even if it is a decimal, are not significant. So the 2 zeros in front of the 6 and 0.00645 are not significant because they're just placeholding that lovely number there. So there's only 3 significance figures in that one. And the other examples kind of explain that as well. Okay, so we have rule number 5. I know I'm going a little fast, guys, but I want to try to make sure that this video is quick and easy for you guys to simply get all the rules down and then do the practice, because this is the only activity that you're going to be doing in the month of June. So, rule number 5. All zeros which are to the left of a written decimal point and are a number greater than 10 are always significant. So numbers that are before the decimal place that are numbers greater than 10 are always going to be significant. So we have 3 significant figures in 870 milliliters. We have 40 in degrees Celsius. What I need you to realize with these examples, though, is that I put the decimal place there to show you if there is a decimal place, it means that I am exactly telling you that it is 170 marbles or 40 degrees Celsius. I really want you to focus that if I have a point anywhere in a problem, like if I tell you that I have 100 kilopascals, I want you to know that that point says, hey, those 2 zeros are significant, you need to count them. That's the main point that I'm trying to get across. So if there is a decimal place in anywhere of the examples that I give you, make sure that you are saying that that 0 right before the decimal place is significant. Okay, so last rule. All counted numbers are significant as well as all exactly defined quantities. So that means 20 students in a class, those 20 students, the 0 there is significant. 12 classrooms in the Moss Wing, you have 2 significant figures there. 1,000 meters in 1 kilometer. So this is where it gets a little hairy. So you may think, okay, 1 kilometer has 1 significant figure, but I'm talking about exactly 1,000 meters in 1 kilometer, so therefore there are 4 significant figures. This is the same thing as 100 liters and is equal to 1 hectoliter. So that's saying that that is equal, so there are 3 significant figures in there because we're just making that number smaller, but we have 3 significant figures carrying over. So let's check out some practice examples with rules number 3 and 4, because here's where things get a little bit hairy and we're going to combine scientific notation into it. Okay, so when we think about this, a helpful way to keep track of rules 3 and 4 when we're changing things into scientific notation is making a mental note of how many significant figures there are there first. So if we have 450,000 millimeters, when we change that, we need to make sure that we're only keeping track of 2 significant figures because there is not a decimal place there. If there was a decimal place there, we do have to make sure that we have those zeros because it's an exact measurement. It's the same thing as saying 0.00058 kilograms. If we change that, we only know that there's 2 significant figures because the zeros in front are not significant. And then the same thing as the last one, we only have 3 significant figures because that 0 is sandwiched in between the 8 and the 9. So we have to make sure that we're keeping that 0. So when we change it to scientific notation, 8.09 times 10 to the 8th meters shows that we still have the 3 significant figures. Okay, but now here's another confusing thing. We're only talking about one measurement, but we know that in chem we have a boatload of calculations. So when combining measurements with different degrees of accuracy, the accuracy of the final number can be no greater than the least accurate measurement. So that essentially means with the least number of significant figures that you have, we need to make sure that we're carrying through the entire problems that we have the least number of significant figures. So if we have 8 significant figures times 2 significant figures, we are going to be left with only 2 significant figures. So, just like I said with multiplying and dividing with the last example that I just stated, the answer is based off of the least number of significant figures in the problem. So we have 23.123123, which has 8 significant figures, but we're multiplying that by 1.3344, which has 5 significant figures. Your calculator is going to give you 30.8555495. That's what it normally does, because it's not going to give you the significant figures. What you are going to do is you're going to have to round it to the exact number of significant figures, which would be the least in this example. So there are only 5. So you're going to have to do 30.855 as the rounded to show that you're using only 5 significant figures. Okay. However, this is different with addition and subtraction. Addition and subtraction, if you have decimals, the answer is based on the least number of decimal places in the problem. So whatever number has the least number of decimal places, for example, we have 150.0 grams of water plus 0.507 grams of salt. When we add those together, it gives you 150.507 grams of the solution. However, we only can record the numbers that are significant, and that essentially means we can only go to the farthest decimal place that the 1 is, which means the least. Essentially, I'm sorry, that's really confusing. Let me back up. I apologize. So what I mean by this is we're taking that 150.0, that 0 after that, that's the least number of decimal places that we can go. So that's the only furthest destination that we have after the decimal. So when we change this to significant figures, it'd be 150.5 grams of solution. So for these examples, you do not keep track of the least number, you more worry about the decimal place. So here are some example problems that I would like you guys to complete. I will have a picture of me going through these example problems as well, just to show you the formatting of how to do these problems. So go ahead and pause the video, complete these 3 practices, and then we'll reconvene after you're done. And make sure that you're checking the answer key that I posted on Schoology for you guys. Alright, so here are the examples. Okay, so when we're dividing, the lowest number has only 3 significant figures, so we can only have 3 significant figures as the answer. So the answer would be 0.439 milliliters. The reason for this is you can only have 3 significant figures because you have 5 on the top and 3 on the bottom. For number 2, we are adding here, but realize that we can only go to 0.70 because that's 2 decimal places after the decimal point. So we can only go that far, so that's why you have 180.60 grams. Okay, so only 2 decimal places after that. For the last one, again, you're multiplying this, so it can only be the least number of significant figures, so that would be 3, because you have 4.27 grams per milliliter times 59.3 milliliters, and you would only get 252 grams, because that leaves you only 3 significant figures. Alright, that's the entire lesson that I have for you. So what I would like you to do is, after watching this YouTube video, log into Schoology under the folder that says Scientific Notation and Significant Figures. Complete that Jamboard that is there. If you have any questions, do not be afraid to message me on Schoology. I will be open to Zooming if you have any questions, making sure that you understand it more a little bit. I understand that it's not fun to do work in the summer, but please realize that this practice will help you through the IB course, and you need to keep everything that you have and you've learned this summer with you to be partial to help you through the IB course and the content that I teach you. Have a great rest of your day, guys. Enjoyed completing that Jamboard. Remember that it's due the last day of June. Bye, guys.